So as you recall, we described chemistry as being the scientific study of matter and its transformations. So another word that is often used instead of transformation is just plain and simply a change, or sometimes we'll use the word process as a synonym for transformation. So process would be another one. So you want to be aware that sometimes we'll use more than one word to describe the same thing. So physical changes are those that do not result in a change in the composition of a sample of matter. And the two big examples of this are when we just divide a sample of matter into smaller pieces. So maybe we grind it up, or maybe we crush it, or maybe we just, cut it into smaller and smaller pieces with something like a knife. It could also mean taking a liquid and pouring it into two containers. That will not change the composition of your sample, so it's classified as being a physical change. The other big category of physical changes are changes of state. This is where we boil something, turn a liquid to a gas, melt something, turn a solid to a liquid, and occasionally we will sublime a substance, which means we turn it directly from a solid into a gas without actually going through the liquid state. Of course, we can go the reverse direction as well. We can turn a gas into a liquid, and that's called condensation. We can turn a liquid into a solid, and that's called freezing. And then we can turn a gas directly into a solid without going through the liquid, and that guy is called deposition. So we can go, in both directions with respect to phase changes. We're going to talk more about phase changes later on, and we're going to become familiar with the names for these particular phase changes. Chemical changes are a little different. Chemical changes are those that result in the composition of a sample matter changing. So a good example of this would be combustion. When you burn something, the composition will change. You will have different materials afterwards than what you began with. Corrosion, where a metal reacts with oxygen in the air and becomes rust. Or decomposition, and decomposition is where a substance simply falls apart into simpler substances. So changes of matter can be classified as either being chemical or physical, depending on whether new substances are formed or not. So one way of classifying matter is as whether it is either a pure substance or a mixture. So a sample of matter is classified as being a pure substance if you can't separate it into multiple kinds of matter by what we call physical means. And physical means just means without breaking connections between atoms. A mixture is a physical combination. That means a combination where we don't actually form bonds between the particles of matter of two or more pure substances. And unlike a pure substances, the components of a mixture may be separated by physical means, that is, without breaking connections between atoms. So example of these physical means might be doing things like filtering something, so running pasta and water through a colander. Distillation, which means boiling off a liquid. Or sometimes if you have a magnetic component, you can wave a magnet over that and your magnetic component will be separated from your non-magnetic component. Pure substances have a fixed composition, but mixtures can have a variable composition. For example, a cup of coffee is a mixture, and you can have a weak cup of coffee or you can have a strong cup of coffee. You might have a mixed alcoholic beverage, perhaps some like bourbon and cola or something. And how strong that beverage is will depend on the relative proportions of the two amounts. If you've ever painted a picture and you know that you don't have paint of every color, what you do is you mix some of your paints together to get new colors. And the exact color that you get depends on how much pigment of each type is added. So, mixtures are composed of more than one pure substance physically intermingled. Mixtures can have a variable composition depending upon the exact amounts of each components that you put in there. You can separate the components of a mixture using physical methods without the need to break connections between atoms. Pure substances have just one substance in them. They have a definite fixed composition, and the components of pure substances cannot be separated by physical methods. So mixtures are often described as being either heterogeneous or homogeneous depending upon their characteristics. So heterogeneous mixtures have the characteristic of having visibly different phases or parts. And in particular, what is key to identifying a heterogeneous mixture is recognizing whether a sample of one region could have a different composition as a sample from a different region. So good examples of heterogeneous mixtures would be things like sand. And you can see both of the qualities that we identified of heterogeneous mixtures in this sand. There are visibly distinct different parts to it. And if I sample over here, I get this kind of clear crystal. But if I sample over here, I get this kind of black crystal. So a sample of one region might have a very different composition than a sample of another region. Here's a kind of heterogeneous mixture with bigger particles. This is some vegetable soup, and you can see that there are visibly distinct parts. We've got some green stuff, we've got some carrot colored stuff, we've got some, it looks like potato or something in there. And if I take a sample over here, I get a bit of potato. If I sample over here, I get some green leafy stuff. And I could separate out these components by physical means. I could run this through a colander and I could separate out the solids from the liquid by way of example. A homogeneous mixture is a bit different. In a homogeneous mixture, a sample of any one part of the mixture would be identical to any other sample. So if I have an alloy, something like bronze or brass, then how this was made was by melting the component metals, stirring them together really thoroughly, and letting them then solidify. And a sample of any one region of my alloy, whether I sample the front here or whether I sample the back, they're going to have exactly the same composition. Another good example of a homogeneous mixture is a solution. So if I take a nice cup of hot water here, add a spoonful of sugar, and give it a big stir, it will have the same level of sweetness, top and bottom. It won't vary in composition throughout this cup of water. So this is where we're at the moment. We've identified that matter is anything that has mass and occupies space. And then we said that matter can be in objects, those objects can have two qualities. They could be either a mixture or they could be a pure substance. Mixtures can have variable composition depending upon the amounts of each component. It's important to recognize that the components in a mixture retain their individual characteristics. You can separate out those different components by physical methods. And yeah, that's kind of important. Now, if you have different components, different amounts of each components, then those mixtures could have like very different properties. And we know this if we look at something like gold that is used for jewelry. As we change the proportion of the metals that are present in gold, when we go from 9-carat gold to 8-carat gold and so forth, we can really change how hard and how tough that jewelry gold is. Mixtures are defined as being of one of two types. They're either homogeneous or heterogeneous. Homogeneous mixtures have an even composition throughout. A sample of one region will be the same as a sample of any other region, and there are no sort of like distinguishable different components in there. Heterogeneous mixtures are kind of the exact opposite. They have visibly distinct parts. That is, the components are distinguishable from one another. And they don't have the same composition throughout. You could sample one region and it would be very different from other regions of that mixture. Pure substances are not mixtures. They are a single substance. They have a fixed composition, and you can't separate out the different, you can't separate out a pure substance into multiple components using physical methods. The only way you're ever going to be able to do that is by using what we call chemical methods, where we're actually breaking the connections between atom types. The properties of a mixture do not vary in any way. Of a pure substance do not vary in any way. Pure substances always have the same properties. And sometimes we use the words heterogeneous and homogeneous to help us understand the physical and chemical characteristics of a mixture. So a good example of this would be if I had a glass of water with some, here's a glass of water with some ice in it. The ice will float near the top of the water. What I know is that this sample here is chemically homogeneous. There's only one substance present. It is the same substance throughout. So chemically, this guy is homogeneous. So chemically, this is going to be homogeneous. Now, physically, because there are two very distinct states of matter present, we would actually say that physically, this guy is heterogeneous. Now, if I just describe this as being either a substance or a mixture, I would say that this is a pure substance because it's kind of water from top to bottom. But I need to make it clear what's really going on here, and so I'd have to add some qualifiers in here. So yes, chemically, it is homogeneous because it's a pure substance. But physically, it's heterogeneous because we've got both the solid state and the liquid state present in the same sample of matter. Okay, so samples of matter can be either a heterogeneous mixture or a homogeneous mixture if they have more than one component to them. Samples of a heterogeneous mixture could be different in composition. However, samples of a homogeneous mixture will always be exactly the same.